Hi guys, Professor Burns here. We're going to take a look at section 3.7, which is on a topic called the chain rule. And this is another method we would use to find derivatives of certain types of functions. Make sure your cell phone is put away and not in your line of sight so that you can take good notes and focus for the next few minutes. So as I've done with product and quotient rule, I really like to use these words. But when do we use the chain rule? First of all, let's establish that. It's anytime we have an inner and an outer function, so the composition of two functions. That's the first thing to establish. If there is one function that looks like it's on the inside of another function, that's when we would use chain rule. You may remember from your algebra classes, f of g of x was the composition. That meant that you had an inner function of g of x and an outer function of f. And so notationally, we would say the derivative, d dx, of f of g of x is equal to f prime evaluated at g of x times the derivative of g, so g prime. And here it is in words, the derivative of the outer function, so f if that's the outer function, derivative of the outer evaluated at the inner, that's the tricky part, evaluated at the inner times the derivative of the inner function. That's the g prime. So let's look at a couple of examples here, and then we'll do some practice in class. First thing you need to do is establish what's the inner and what's the outer. And I'm going to write those in words rather than using the notation f and g, because I want them to be more generic, since it may not always be f and g. So in this example, what function is on the inside of another function? Looks to me like 2x minus 5 is on the inside, and it's on the inside of the function x squared. Make sure you see that. If you were to compose 2x minus 5 into x squared, that would give you the function they're giving us here. So to find the derivative, y prime, I'm going to use the words here. It's the derivative of the outer, so x squared, but evaluated at the inner. So I always put like a big parentheses there, kind of like a shell. Don't put 2x, put 2 and then parentheses where the x would have gone. So derivative of the outer evaluated at the inner, so 2x minus 5, times the derivative of the inner, which is just 2. And that's it. That's your chain rule. And you can simplify and clean this up if you wish, but of course you do not have to. This is fine. If you check the answers in the back of the book, you might end up with 8x minus 20, but this is fine as the answer as well, what we started with. All right, let's try the next one. They want us to find the derivative of sine of x squared minus 4. So when you have a trig function, whatever is inside the argument is going to be your inner function. Please remember, this is not multiplication. This is not sine times x squared minus 4. It's not a product rule. This requires a chain rule because the argument is x squared minus 4. That's on the inside of the sine function. So x squared minus 4 is the inner function. That's on the inside of the sine function. It has to be sine of something, so we'll say sine of x. So here we go. The derivative of the outer is the derivative sine, which would be cosine, evaluated at the inner. So we're going to put parentheses, evaluated at the inner, x squared minus 4, times the derivative of the inner, which is 2x. And that's it. That's your chain rule. And again, if you want to clean that up a little, you might want to put 2x in the front. So it's 2x times the cosine of x squared minus 4. However, that is not necessary. You could leave it the way you started with to begin with. And that's it for example. So we will do plenty of practice with this in class. This is a really important rule that we're going to be using throughout the semester. So make sure you bring your notes with you, and I'll see you in class.